All right, Kyle, here's your last video. In these ones, these are the problems that we worked on where you want to change all your tangents into sine divided by cosine. You want to look for Pythagorean identities, and you're trying to verify each one of these. So in here, you would change this cotangent into a cosine over a sine, and you would try to show that it equals 1. These are really not too challenging. I'll be really honest. You need to find a common denominator in this one, but that's really all there is to that one. And then in here, in these guys, this is about solving your trig identities. So what you want to do is you want to balance these problems to solve, and I'm going to do number 3 with you. Let me show you 2 real quick. So in number 2, 2 sine squared x minus 1 equals 0. I want to balance this problem to get the sine function by itself. So I'm going to add 1 and divide by 2. I get sine squared x is equal to 1/2. And then just like any other squared function, I want to square root. The square root of 1/2 is the square root of 1 over the square root of 2. And remember, you can't have square roots in the denominator, so I'm going to multiply by radical 2. So I'm getting the sine of some angle is going to be equal to radical 2 over 2. And the other key bit is that when you square root a function, it could be the positive or negative version of that, because this times this negative, a negative times a negative would give you a positive. For this problem, I want to know when is the sine function equal to radical 2. And that happens in 45s, right? That happens at 45 degrees. It happens at 135 degrees. It happens at 225 degrees. And it also happens at 315 degrees. Or pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so that's what it means to solve. I know this is not this problem, it's this guy down here. You want to balance and then figure out the angles that are associated with this value. Okay, same thing happens with this one, but here you have to use factoring techniques to be able to solve it. So notice how there's a sign in both of these functions. I'm actually going to do this one underneath. I'm going to pull out a sine x, and I get sine x plus 1 equaling 0. And then I can set each one of these equal to 0. So the sine of x could equal 0, or the sine of x could equal, plus 1 could equal 0. And then if I balance this, I get the sine of x is equal to negative 1. So when on my unit circle is the sine function 0? Well, that happens in 2 locations. At negative 1, 0 and at positive 1, 0, right? That's when my sine value is 0. So that could happen at 180 and 360, or pi and 2 pi, or even 0 if you want to call it. And 1 is equal to negative 1. There's only one place that happens, and that's at 270 degrees. Right here it's positive 1, so this is at 3 pi over 2. All right, so hopefully that helped. Definitely text me if you have questions. I have church tonight, but when I get home, I'll definitely look at my phone. All right, good luck studying, kiddo. I'll talk to you soon.